fraction exponents. So after figuring out that 2 times 2 times 2 could be written as 2 to the power of 3, some guy said, all right, smart aleck, what about 2 to the power of 1/2? Ha-ha, what's that? Bet you didn't think of that one, did you? No, of course, an easy answer would be, well, you can't multiply 2 by itself just half of a time. But you and I know that there's always a way to do something in math except division by 0. Nobody's ever found a useful definition of division by 0. So there we really do just say, you can't do that. But 2 to the power of 1/2, somebody long ago thought of a useful use for that. And the reasoning goes like this. Supposing I take 2 to the 1/2 and I square it. In other words, 2 to the power of 1/2 raised to the power of 2. Well, we've got that lovely rule that says if you are raising a power to a power, you multiply the exponents. So that should be 2 to the power of 1/2 times 2. And 1/2 times 2 is 1. In other words, it's just a 2. So 2 to the 1/2 squared gives us a 2. Well, if something squared gives us a 2, then that something had better be the square root of 2, right? So we define 2 to the power of 1/2 as the square root of 2. We don't even have to know what it is, although it's been worked out to be about 1.41. But the key thing is we now have a definition. Likewise, if we do anything to the power of 1/3, let's just do x this time. X to the power of 1/3. Well, supposing I raise that to the power of 3. 1/3 times 3 is 1. So that means that x to the 1/3 cubed is x, whatever x is. And that means that if there's something that you can raise to the 1/3 power and get x, that something must be the cube root of x. And so it goes for 4th roots, 5th roots, any roots you want. A base to the power of 1 over a number is that root of the number. 2 to the 1/2 is the square root of 2. 3 to the 1/2 is the square root of 3. 4 to the 1/3 is the cube root of 4, and so on, and so on, and so on.